Okay, so this is just a quick review on how to graph logarithmic functions. There is multiple ways that you can approach this, but what we did was we looked at what the base was. We used a base of 2 in this particular case. And then if you remember a logarithmic function, the values are have a base of 2 in x instead of y, like we did for an exponential, since it's the inverse of an exponential. So instead of counting 0, 1, 2 in x, I'm going to count 0, 1, 2 in y, and then I'm using my base 2 in x, which is going to be 1, and then times 2, and then times 2 is 4. So those were our parent function values for a logarithmic function with a base of 2. So now we're going to look at our transformations, which means we're going to go right 3 and up 1. So we're going to take our coordinates and go right 3 and up 1. So in x, I'm going to add 3 to the x values, and I'm going to add 1 to the y values. So my new x values, 1 plus 3 is 4, and then so on. I'm going to get 5 here, and then 4 plus 3 is 7. I'm going to add 1 to the y value, so I'm going to get 1, I'm going to get 2, and I'm going to get 3. So my graph is going to go 4, 1, and then 5, 2, and then 7, 3. So here's my graph, and if you remember, we need an asymptote here as well. So again, if our normal function has an asymptote at x equals 0, we can tell this is move right 3. It's going to have an asymptote at x equals 3. That just makes sense, right? So in addition to that, what I want to make sure you understand is that value for the asymptote is always found by taking whatever's in parentheses, x minus 3, and setting it equal to 0. So that way, if you have a dilation or something else going on, you can always solve for it this way. So you're going to add 3, and you get x equals 3. And then you can see you're just going to come around, hug this asymptote on this side, and come around and graph the rest of the function. Okay, so in this second example, you have an additional feature here, characteristic. It's going to have a negative up front, which means it's a reflection over x. So my transformations are reflect over x, and then it is going left 1 and up 2. Okay, so here's my base 3 points. Again, I'm counting 0, 1, and 2 in y instead of x, and then my base 3 is 1 times 3 is 3 times 3 is 9. So those are my original coordinates for a logarithmic function with a base of 3. Now I'm going to do my transformations to it, and it's going left 1, so I'm going to do x minus 1, and it's going up 2, so it's y plus 2. But if you remember, a reflection over x changes the y coordinate to the opposite sign, so it's going to be a negative y plus 2. So I'm going to subtract 1 from all of these. I'm going to get 0, I'm going to get 2, and I'm going to get 8. I'm going to take negative y plus 2 for my y coordinates. So negative 0 is just 0 plus 2. And then negative 1 plus 2 is 1. And negative 2 plus 2 is 0. So here's my coordinates, 0, 2, 2, 1, and 8, 0. Okay, so here you can see the graph is going to go this way. Now, where is that asymptote? That's the other feature you want to make sure you get correct. So x plus 1 equals 0, and that means x is going to equal negative 1, which makes sense because the graph moved left 1. So at x equals negative 1, that's your asymptote, and you're going to have to make sure your graph comes around and hugs that asymptote and comes around and connects to your graph. And that's a quick review of graphing logarithmic functions. Now remember, you can have additional things like a dilation, a vertical dilation, and a horizontal dilation, and that would affect your values here as well.